Welcome to Science by PK. Today we're diving into the fascinating mysteries and downright mind-bending world of quantum computers. These aren't your average laptops or desktops. They're something straight out of a science fiction movie, but they're very real and are set to revolution the way we think about technology, science, and even artificial intelligence. So grab a comfy seat and let's explore the quantum universe together. Oh, don't forget to like and subscribe and share the video. Let's make science fun for everyone. Okay, let's start with the basics. The quantum computers as we know them today, the computers that you know today, you use them to watch videos, work, using bits. Think of a bit as light as a switch, either on, 1, or off, 0. Every piece of data you ever seen on computers made up these 1 and zeros. It's like flipping light switches a billion times per second. Impressive, right? But quantum computers don't have regular bits. Instead, they have core bits, short for quantum bits. Here's where things get crazy. Core bit isn't just a 1 or a 0. In quantum mechanics called superstation, orbit can be a 1 and a 0 or something in between. All at the same time. Imagine spinning a coin in the air. It's not heads or tails. While spinning, it's sort of both. That's what superposition is like for core bits. And if that wasn't if that wasn't mind-blowing enough, there's another quantum trick called entanglement. When qubits are entailed for the state of one qubit connected to the state of another. No matter how far apart they are, it's like having a pair of magic dice roll on one die in the New York and the other die in Tokyo, which will always match no matter what. Einstein famously called this spooky action at distance. Spooky but true. So why does this all matter? Well, when you combine superposition and intertanglement, quantum computers can process an unimaginable number of possibilities at once. A traditional computer would need to wrest every possible solution for a problem one at a time. A quantum computer, thanks to its qubits, can test all the possibilities simultaneously. It's like being able to read every book in the library at the same time. But don't throw out your regular computer just yet. Quantum computers aren't better for everything. They're better for certain types of problems. For example, they're excellent at solving problems in cryptography, chemistry, and optimization. Here's an analogy. If you're trying to untangle a giant ball of yarn, a regular computer might slowly pull at each thread one by one. Quantum computer, on the other hand, will look at the whole ball at once and find the best place to start pulling. Let's talk about the physics behind these magical machines. Quantum computers with the tiniest particles in the universe. Building a quantum computer isn't to operate it in extremely controlled environments. Most quantum computers are kept at temperatures colder than outer space. It's because even the slightest disturbance, like a tiny vibration or heat, can mess up the dialect of quantum state and its qubits. Now let's get into the fun part. Future elections. Quantum computers expect to revolutionize artifacts and artificial intelligence. Training AI models takes days or weeks on classical computers. It could take hours or minutes on quantum computers. But imagine an AI so smart it could solve problems we haven't even thought of yet. But don't worry, this doesn't mean robots are taking over. It just means our tools are getting better. Quantum computers can also transfer medicine. Scientists could simulate a complex molecule to discover new drugs faster. Think about it. What if we could find a cure for cancer in years instead of decades? And logic is, quantum computer could optimize delivery routes for millions of packages in a second, saving time, money, and energy. Here's a fun fact. Quantum computers are still in the early stages. The most powerful quantum computers today only have about 100 qubits, and they're still prone to errors. It's like building the first airplane. You know it's gonna fly, but not yet ready for commercial flights. Companies like Google, IBM, and startups like Rigetti and racing to build bigger, better quantum computers is like a modern day space race, but instead of the moon, the goal is quantum supremacy. Now, I know this all sounds very futuristic, but let's put it into perspective. Classical computers took decades to become part of everyday life. Quantum computers will likely follow a similar path. Today, they're used in research labs, but tomorrow, they could be helping us design climate change solutions, develop AI, and even explore mysteries of the universe. But before we wrap up this video, let's leave you with a fun analogy. If classical computers are like bicycle, simple, reliable, and great for most tasks, quantum computers are like teleporting machines. A bit unstable right now, but we can figure them out. They'll take us to places that we can't even imagine. Thank you for joining us on this video.